Okay, welcome back. Today I will discuss the transient phenomenon. This is the fifth lecture of the G30 International Program in Nagoya Universities. And in the last lecture, I have mentioned we will analyze the drive circuit. Why we require the drive circuit in power electronics systems? Because of the input side and output side voltages are almost the same. Why require? But to analyze this drive circuit, we must require the basic knowledge. And the basic knowledge is the transient phenomena. In the power electronics, is composed of the inductor and the capacitor. Inductor and capacitor is the passive component. And more, we require the power semiconductor devices. That is the switch. That is the switch. And each power systems and this triangle waveform generator and drive circuit is composed of the resistance and capacitor. So we must analyze this equivalent circuit. So this is a very simple one, but for obtaining the knowledge, we must analyze this circuit. So before this discussion, I will talk about the transient phenomenon. Okay, very easy, very easy. But my lecture is not require the differential equation. Only using the Ohm's law. Okay. For my original analysis method is composed of these three steps. One is the variable, for example, the voltage or current with the variable increase or decrease. And the next step, obtain the equation VC or IC, VC, and finally, we will obtain the time constant. Okay. Okay, let's discuss. Mic. If we remain this capacitive component or inductive component, for analyze the circuit, we must use the differential equation, but that analysis is complicated. So we in this lecture, for analyze this circuit, we looked at this passive component, inductor or capacitor, look the switch. We will draw the table. T equals 0 or T equals infinity. And the time we can draw the C or L, inductor or capacitor. And in case of T equals 0, in this table, please fill this table. T equals 0 or T equals infinity, we can draw the switch. we can indicate the switch in case of this time, each time, turn on or turn off. How about the C? How about the L? Please fill this table, okay, in your notebook. In my image, the capacity is the bucket, and what else? The switch is open, the water flows through, and what else? This story is higher and higher. This is my image. The higher, this value we see, and this current flow is IC, and the T equals 0. In case of the T equals 0, the charge is 0. VC equals 0 in T equals 0. No charge, so current can flow through to this bucket, and in the infinity, the filled the bucket, the current cannot flow through, and VC is the max value. So the first T equals 0, current flow through. So switch is on. And infinity, T equals infinity, the current cannot flow through because of the fill the bucket. So this means the off. And L is the opposite. And on. This is my image, but please image in yourself. Make the image in yourself. Okay. And this one. よいしょ。ここはイメージだけだからね。In that case, next step is the variable is increase or decrease. So please check using this equivalent circuit. Okay. In case of the T equals 0, the equivalent circuit is the capacitor is indicate that switch turn on. So this is a ideal switch, so that we can draw the equivalent circuit is here like this. This is the equivalent circuit in case of the T equals 0. That is the V and R. Because of the C is the ideal switch, so we can do only the conductor line like this. How about we'd like to obtain the VC and IC's equation and waveform. In case of this circuit, IC is, of course, very easy also. VC 0 because only the line. Okay. And how about the T equal PT? Open the switch. Of course, the open the switch, I equals 0. V input voltage. Okay, very easy. And next step, increase over decrease. We will indicate the waveform from now. We will draw the T VC IC. Please draw the each waveform. 0, 50. T equals 0, VC equals 0. Okay. In this time, V. Right? Voltage is increase. Okay? In the transient phenomenon, world, this world is have the law. In case of increase, the waveform is shaped like this. Decided. Okay? And how about the current? Current is indicated in case of the 0 times 0, we see. In this time, decrease. In case of decrease, in the transient phenomena world, the curve is decided like this. The shape curve is decided, so the equation is decided. That equation law is the transient minimum and maximum. That transient means that like A. This one is okay. I will draw this term. In this shape mean the transient is A. This waveforms indicate the A minus time. I have indicated that the time constant is T, large T. Okay, and that's the lower side. The transient is lower value, and the upper values between this transient is B. This curve indicates B, E minus. The shape, each shape's equation is already decided. So please remain only this equation in your brain, okay? Only this one. So in this case, this red line indicate the VC. So VC indicate the transient value is the V, and decided this one. And this one is the IC, indicate IC, decide it, and using this law. Okay. Please remember only this law, shape, and the relationship of this curves and equations relationship only. So you can obtain each equation easily using only the Ohm's law. Okay. And finally, the barrier one is this one, T, large T. So this large T is the time constant. So let's obtain the time constant. Okay, I will remove this one. Okay, third step. めっちゃ腹減った。Third step. How to obtain the time constant? First step A is remove the power source. Remove power source. Step B. The series connection. Obtain the series connection equivalent circuit. Obtain the series connection equivalent circuit. わけわからんね、これ。series connection equivalent circuit. And step C, obtain the time constant. Okay? Remove our targets. First target is this equivalent circuit. Equivalent circuit is here. In case of the switch turn on, we can obtain the equivalent circuit. And next, remove this one. And obtain the series connection equivalent circuit. Obtain almost the same one is, but CR. In this case, time constant is decided only this value RC. Okay. So series connected this equivalent circuit, we can use this laws directly RC. We can apply this value RC. Finally, we use this three step. We can obtain the equation, each variable equation, and we can obtain the shape this waveform. That is not using the differential equation transient phenomena. And using this phenomena, let's discuss the power electron system. For example, the drive circuit and the power circuit, and how to generate the transient waveforms. Okay, that's all of this fifth lectures. Please remember this fundamental knowledge. Okay, see you. お疲れ様でした。